All right, welcome class. So this is another homework help, but it's a little bit of content that this first part of it will be a little bit of content that we didn't get to in class, and it will help you understand some differences in computer languages. And then the next part, the next little short video that I'll put up with will directly take you through some of the homework stuff in Ruby and how to do this. So the part of the content that we didn't really cover as much as I wanted to, I've thrown this OOP up there, but I haven't really explained it. OOP stands for Object-Oriented Programming. So when you see OOP on something, it means they're talking about objects. They're talking about things like Scratch, where um, where an object has its own variables, and it has its own methods or blocks or procedures, things it can do. Like it has its own actions it can do. And so things which are objects which have those things and then those objects interact, that's object-oriented or OOP. Procedural programming is more, as I've said before, is more step 1, step 2, step 3. Scratch is fully object-oriented as you encounter it in the Scratch thing. There's no extra place to put code. You can give the backdrop code, but the backdrop itself is an object. So all these things are objects, and there's no extra place to put code. As we'll see in the next video, when I take you through the Ruby homework, Ruby is a hybrid. It does both. There are places where you can have code in just the objects, but there's also places where you can have like do this first, then that next Ruby, kind of thing. C is procedural. Do this, then do that. C++ is C with objects in it, but in general, so we're going to be doing C with our procedural C with Arduino in this class, just so you see the difference. That's what I want you to see, the difference in different kinds of languages. Now in class, I've mentioned the NASA application. In class today, I mentioned my father has a pacemaker, and things like the NASA launches and things like a pacemaker, you want absolutely no surprises with those types of programs. And so that's where you're more likely to use a procedural language like C. As I mentioned, NASA didn't want us to even use something like Java when we programmed with them about 10 years ago. They might have changed since then. But they want to be very sure they know where everything is, and they want to know when everything's happening, and it just want everything visible. Same thing with like a medical device type of thing. You might want to do that. But we're going to see that object-oriented programming can surprise us, and that's a good thing, right? So OOP is, the way it works is objects, in a purely object-oriented thing, objects listen for events. Okay, we'll talk a little bit about that. They listen for events. They react using their own internal methods when they quote unquote hear something, when an event triggers, right? In procedural, we tell the computer, do this, then that. And in procedural, we should not be surprised. We have been a bad programmer if we are surprised with procedural programming. But surprise can be a very good thing. So one of the classes I teach in programming is game design and simulation. And there was a very important thing about how do we simulate murmurations. Things like swarms of birds, schools of fish, lots of little particles happening together. How would you simulate things moving in the wind, different types of things? So computer programmers in the late 80s were really struggling with this, and it was thought to be maybe it was an unsolvable problem because nobody could come up with a procedural program, which is what the languages were then, that would really like solve for all these complicated shapes that you could get. But it turned out that with object-oriented programming, it went from impossible to solve to 3 simple rules. So the man who solved this, his last name is Reynolds, and he solved it with a paper he published in graduate school that had 3 simple rules, and it solved it. It was called the Boids, and it was a really big deal in computer science. And each Boid, which is like a bird, object, had 3 rules. It would try to be in the center because it's safer there. You want to avoid like predators and things. It would try not to run into things, including other Boids. So sometimes if there's too many Boids in the center, it would move to the edges, right? And it would try to keep up with the other Boids. You don't want to be left behind by the flocks, right? And this turned into this beautiful and surprising and wonderful thing That really does. This is a JavaScript simulation of it. There's also, if you go to Khan Academy, and I'll try to provide that link, there is a Java script version of this you can play with there. And this is just, it seems like these are almost living things, and they do surprise us. This one looks more like schools of fish kind of thing, but it's really wonderful. So sometimes you want your code to surprise you. If you are using your code to try and solve a problem and try to model something in nature, you're using it as a scientist, you want to discover something new, well then you might want your code to surprise you with the answer, right? And that's object-oriented stuff is good for that. Okay, so in object-oriented code, the general plan is that there are messages sent out, there are events that get sent out, and each of these guys, these little objects, have something that listens. So when I receive speak, I will speak, right? Each of these three guys, and then they have their own reaction to what that means, right? They have their own behavior for what speak means. So this is a listener or an event handler, and that's how object-oriented stuff works. Now, we looked a little bit and said, well, underneath the hood, the computer is really dividing this up, right? But we as the programmer don't have our hands directly on that. We're not directly telling it. The computer is sort of telling it this stuff. So we're going to look at doing a little, if I can squeeze it into this video. Okay, here I have Avery, and Avery has one behavior that when I click on Avery broadcast speak, and Fred has one behavior that when he receives speak, he speaks. So very, very easy, not really surprising stuff. Okay. Puppies have a behavior that if they hear other puppies barking, they might start barking and then everybody gets barking and then it's a whole crazy barking mess. So let's model that behavior. Okay, to do that, I added a variable called barkiness and I set that to 0.5. And you'll notice that in his speak method now, he says arf, which causes that output, but then he also broadcasts the message, someone is barking. We go to events, and this is a way of using a listener. These are all listeners. Okay, when I receive someone is barking, I'm going to add a little bit of randomness to make this seem more realistic, because sometimes they're in a barky mood and sometimes they're not. Okay, and I'm going to use an operator. Okay. This is my condition that's going to be evaluated true or false. And I'm going to say if my barkiness, which is 0.5, is less than, I'm going to get a random number. If you haven't done this before, it's really fun. And I'm going to pick a random number from 0 to 1. And I just want to make sure, because I haven't done this in a while, make sure that I can see well, no, we'll see. We will see. So if my barkiness is less than this random number, oh, I should make it greater then. Okay, let me switch this over. If my barkiness is greater than this random number, then I will speak. Okay, now notice that up here, I had to put this in a forever loop so that it keeps looking for whether the mouse pointer is touching it, right? And so I had to put that in a forever loop so it keeps going back. Listeners are like that forever loop. In fact, they're coded behind the scenes very similar way, that they're always listening and comparing for the messages, okay? But the code knows better how to handle the messages than it does one of these loops, so it's more efficient to use messages. Okay, so let's run this. And I'm going to speak. I'm going to say arf. And he only says it once. So I think oh, wait, I should have him say arf for 1 second. Probably going to run out of time, so this will be in the beginning of the next one. Maybe. Okay, it's definitely going to be in the beginning. Well, I'll splice these together. Okay, so I'm going to stop the recorder and I'll splice this together before I send it to you guys. All right, just a sec.